Welcome back for another lesson. One of your answers from yesterday's Jamboard questions made me realize that I made a mistake when I called you entomologists. Entomologists are scientists who study insects, and isopods are not insects. You are so smart, fourth grade, so thank you for helping me learn. All right, my environmental scientists, let's continue. Yesterday, we observed a couple of isopods. Do you remember what they were called? This is the pill bug, and this is a sow bug. Let's review our questions from yesterday's Jamboard activity. Question 1. What did you know about isopods before you observed them? Let's take a look at some of your answers. Some of you didn't know isopods existed. Some of you didn't know that pill bugs roll up. Some of you knew that they had dark colors. A couple students knew that isopods are not insects. And some people didn't know that there were two types of isopods. Well, actually, there are many types of isopods, and we're looking at a couple of them this week in our investigation. But I know that you will learn about many more types of isopods as you move through your science instruction. What did you find out about isopods by observing them? Students found out that sow bugs can flip themselves using their antennae, pill bugs curl up, and isopods move more than our mealworms. Yeah, that's true. All right. Let's take a look at these other questions. What differences did you observe in the structures or behaviors of the isopods? So the question was asking you to compare the pill bug and the sow bug. So these are some of your answers. Sow bugs are flat and pill bugs are dome-shaped. See that? Relatively flat. And then the pill bug has like a dome shape. Pill bugs can roll into a ball, and a sow bug can right itself. Do you remember what it means to right itself? It's when it uses its powerful antennae that it normally uses for sense to help flip itself over if it gets turned on its back. A pill bug cannot do that. All right, great answers, great answers. What questions do you have about isopod structures and their functions, or about isopod behavior? So here's some of the things that you guys are wondering about. Why do isopods have their shapes? It's a great question. How do pill bugs roll up? Why don't sow bugs roll up? What do they eat? Are they born that way, or do they pupate? That's a great question. And how do they survive? So I'm very curious to learn the answer to these questions too. Later this week, you will have a reading all about isopods, and we will make sure that we answer the questions that aren't answered in that reading throughout the lessons this week. So like good scientists, let's get to drawing of your isopods. In just a moment, I want you to draw your isopods on the Investigation 1.2 page of your science notebook. Here are my drawings of the pill bug and the sow bug. Remember, you don't have to be a good artist. You just have to be able to draw to help you understand what you're learning about. So here again is a better picture to help you with your drawing. So please go ahead and pause the video to sketch your isopod drawings. Just like in my science notebook, please label your drawing Figure 2 Isopod Drawings. Please pause the video and draw your isopods. Your darkling beetle drawings were amazing. I cannot wait to see your isopod drawings. But while we're still in our science notebook, please also write down our focus question. Follow along as I read. What moisture conditions do isopods prefer? Go ahead, pause the video, make your science notebook look like mine. All right. Again, our focus question is what moisture conditions do isopods prefer? So here's a new vocabulary word, but it's talking about something that you already know about. Environmental factors. Do you remember the living and non-living factors of an environment? Let's take a look at our question right here. What living and non-living environmental factors should we consider in designing an environment for the isopod? Think back to our lesson from last week about environmental factors. Remember the living factors and non-living factors. We're going to test different environmental factors to determine which conditions isopods prefer. Conditions are the factor of an environment such as food, soil and plants, the amount of light, air temperature, and the amount of moisture, and space. The amount of moisture, air temperature, light, soil and plants, and food. The environmental factor we will be testing is moisture. So follow along as I read this question. How can we set up an investigation to find out how much moisture an isopod prefers? So this is our question that we're going to be answering. We're going to go ahead and set up an experiment. And if we were in the classroom, you know that you would be doing this. But since we're in remote learning, I will be doing it for you. How can we set up an investigation to find out how much moisture an isopod prefers? So let's think about moisture, all right? And I have an example to help you compare it to your everyday life. I think about this experiment like how much milk fourth graders would prefer with their cookies. I love cookies. So would you like no milk with your cookies? Would you like a glass of milk? Or do you need an entire gallon of milk with your cookies? So that's what we're looking at with the isopods. So here's how we're going to set up our investigation, okay? Go ahead and pause the video and read through the investigation setup. That way, when I show you some pictures and some videos, it'll make a little bit more sense. All right, so here we have 100 milliliters of soil, 1, 2, and 3. We have added water. Well, we haven't added any water to the dry soil. We've added a little bit of water to our wet soil, and we've added a lot of water to our moist soil. Let's take a look at that. So here you have a little bit better of a photo. As you can see, there's no water here in the dry soil. It's a little bit of water in the wet soil, and there's a lot of water in the moist soil. So can you see the difference between the soils? All right. Now what we're going to do is we're going to introduce our isopods. As you can see, here's our pill bug, and here is our sow bug, to the soils, and let them determine how much milk they prefer. How much moisture they prefer with their cookies. Soil. Let's see how much moisture the isopods prefer in the soil. Here's our pill bug. Here's our sow bug. This is our dry soil. This is our wet soil. So it looks like our pill bug is making its way to the dry soil, and our sow bug is making its way to the wet soil. So we took a look at our isopods in our different soils. What do you think will happen if we give the isopods more time to explore their environment? In our investigation video, we only watched the isopods explore their environment for about a minute and a half. So I want you to think about what would happen if we gave the isopods more time. Do you think they had enough time to decide which type of soil that they prefer? Or do you think they would need more time? We'll come back to this question in tomorrow's lesson. Let's go ahead and stop our isopod environment design lesson there. I want to take a moment to talk to you about an activity we have for tomorrow. Tomorrow, I want you, with your parents' permission, to go on an insect scavenger hunt. These are one of my favorite things to do. We're going to search for insects. That way we can observe their structures and functions. Think about where you want to search for your insects. Will you search in your yard, near your home, or maybe a nearby park? We will collect and observe our insects for about 15 minutes outside tomorrow. That way you can get away from the computer and enjoy the great weather we've been having. We'll need some supplies for tomorrow's insect scavenger hunt. Please take the time today to make sure that you have a container and a spoon. Maybe you can add some of the insects you find tomorrow to your terrarium. I cannot wait to see what you find. Have a great day, amazing Osprey students.